and welcome to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 1.4a, and it's entitled Newton's Second Law. And so our purpose for this lab is to explain exactly what is a force and how to add forces together, then to explain how the acceleration of an object depends on the force applied, and then objective 3, explain how the acceleration of an object depends on mass. And then in part 4, we're going to take those two principles and put it together to derive Newton's second law of motion. And then in part 5, we're going to use Newton's second law of motion to calculate how far an object is going to go and how fast it's going to be going. So the simulation that we're going to be using is a PhET simulation, and so you want to go to the internet and then open PhET forces and motion. Okay, and then when you open it up, this is what you're going to see. And the one that we want to do first is the net force, so we're going to be clicking on this one. Okay, so here is the simulation that we're going to be using. Okay, so let's go back to the lab, and the first thing it says to do is to put a blue child on the rope and then press the go button. So we need to find a blue child. We're going to put him on the rope there. We're going to click the go button. Okay, and so there's a couple of things you should be noticing. So what is the child doing to the rope? And then in what direction is the oar cart moving? Okay, so that's important. And you're going to put that information into the lab. Now, ultimately, you're going to be filling in this chart down here. So we started off with the blue child, and then what was the force that the blue child was exerting? So you're going to write that here. And then what is the total force? Well, it's the same thing as this thing over here. So you put the same number here. And then in what direction does the oar cart go? So you're going to fill that in right there. And then fill this in. So a push or a pull is called a something. Begins with the letter F. Okay, put that in there. And then what direction does the cart go? Okay, now we're going to click on the values button. So going back to here, if you click on up here where it says the word values, so that's going to tell you exactly how much force that the blue child is exerting. Okay, so that's given by this thing right here. And then, so that would be the number that you would put into that chart. Okay, now we're going to reset it. Okay, let's go ahead and put the values back on there. And you can hear it's got sound effects that goes with it. Okay, so put the blue child and a red one on there. So now we're going to have two, a blue child and a red child. So you're going to want to put down the magnitude of the force here and here, and include the sign convention. So do you remember what the sign convention is? So that means that things that are going up are positive, down is negative, and then to the left is negative, and then to the right is positive. So don't forget to put the sign convention on the numbers that you're putting into this chart. Then run the simulation and then see what happens. It should not be very exciting. Remember to write down what is the total force that's being exerted, and then what direction, if any, does the OR card go. And now we're going to select a blue adult and a red child. So reset the simulation, click on values, and then this time we're going to have a red child and we're going to have a blue adult. So write down what their forces were, and then what was the total force. Another name for this would be the net force or the sum. So all of those words, they mean the same thing. Total force acting, the net force acting, or the sum. So all three of those mean the same thing. Okay, once you've done that, now you can fill this in. So the blank force acting on an object is what causes it to move. So put a word here that makes that sentence make sense. Alright, so we're done with part 1. Let's take a break, and when we come back, we will do part 2.